All right, here we go. Our objective for today: I can identify, define, graph, and graph relations and functions. Let's read it together. 1, 2, 3. I can identify, define, and graph relations and functions. So title your notes, relations and functions, please. And it's still part of the two-variable equation, so today you don't need a Fourier model. What you do need to do is write some steps and also some definitions. So loosen up your wrists because you got some writing to do. Yay, writing. So here we go. So write this down, please. Steps. Number 1, represent the order pairs as a table, mapping diagram, and graph. Step 1, represent the order pairs as a table, mapping diagram, and graph. Step 2, identify the domain and range of the relation or function. Identify the domain and range of the relation or function. And step 3, define the relation or function. Step 3, define the relation or function. Copy those, please. All right, circle these keywords for each step. Step number 1, represent. Step number 2, identify. And step number 3, define. So pretty much step 1, we're gonna represent the order pairs in 3 different ways: table, mapping diagram, and graph. Step number 2, we're gonna identify the domain and range. So I want you to make sure that you understand what a domain and range are of the relation or function. And at the end, I want you to understand what's the difference between a relation and a function. Okay? All right, let's move on. So copy this down, please. Definitions. We need some definitions for terminology. So copy this down. First one, order pairs. Order pairs are a coordinate. In parentheses, you write x, y, where the x is on the left side. It represents the number, whatever number that you put in for the coordinate. And the right one represents y. So any number that is found on that parenthesis on the right-hand side represents the y. Okay? Underneath the steps. Okay, so order pairs. So if I was to give you a lot of order pairs, pay attention, please. If I was to give you a lot of these, let's say I gave you the order pairs 1, 2, 5, 6, 23, and 10. A lot of order pairs, all of them together have a name. When you collect them all together, they're called a relation. Write that down. Relation. A relation is a collection of ordered pairs. A relation is a collection of ordered pairs. And right now I'm going to show you an example of all of these, so like that you can have a clearer idea. And I'm going to do a different introduction than the book, so like that you can see it. Hopefully it makes sense the way I introduce it, okay? Now, relations are a collection of all those points. But there's a special type of relation. There's a relation that is very specific. That kind of relation is called a function. What is a function? A relation that assigns exactly one output value for each input value. And like I said, right now it might not be making sense. Some of you saw this last year. However, maybe it didn't make sense, so hopefully we'll clarify that this year. Remember, this is the year of the Y, right? Okay? So, order pairs, we already know. Relation, we already know. Functions, we already know. Next. From now on, when you see me talking about output and input, they have a particular name. An input, for example. Input has the name of domain. Input is named a domain. What is a domain? It is all x values. Domain, input, which is all x values. Domain, input, which is all x values. So if the domain is all x values, what do you think the range is?
All y values.
All y values, and that's what we call the output. So I'm going to go ahead and do a formal introduction to relations and functions, okay? So here we go. Relations. Now, what is a relation? Let's find out. I already gave you the definition. The formal definition says a collection of coordinates, right? A lot of coordinates together is a relation. However, I like to introduce this and apply it as to our daily life and see how. And you guys understand that I usually see math in a lot of places, right? And you guys are like, really? Yep. My wife says the same thing, says that I'm kind of weird because I see, sometimes we're in the movies and all of a sudden I'm doing math because of something that I see, but I can't stop my brain. So let me just show you how I see relations and functions, okay? Here we go. Now I'm going to say a word that you probably never heard before. Here's the word. Pay attention, please. Everybody look up. The word is Walmart. I'm pretty sure everybody's seen that before, right? Yes, yes, you have. So check this out. The first thing that we do when we walk into Walmart, everybody look up, check this out, you see one of these. Everybody see that? Yes? So you see a vending machine, focus. So they, what? Yeah, this one is 23 cents, yes. Too fresh. So, no, they're regular size. So, let's imagine, like next week when we're gonna be in break, I'm pretty sure you're gonna have a little trip to Walmart or the market, right? And as you're in your room or wherever you're at with your mobile device, you're well, maybe not you guys. You guys don't message anybody. As you are there, oh my goodness, sorry, hold on. As you are there, give me a second. All of a sudden, your parents are like, get ready, because we're all going. And you're like, oh man, and then all of a sudden you're messaging with someone, you're like, you know what, I gotta go because I'm going to Walmart. And then they're like, oh, come pick me up. So then you're like, let me tell them, yes. And they say, oh yeah, let's take the van so we can pick you up and everybody else. So anyways, so that you start picking up people, you get a Walmart, you're in there with your posse, hanging around, and then you get tired, and as you're finishing your shopping, you start leaving, but as you are exiting, you see the vending machine, you're like, you know what, I'm thirsty. I'm going to buy myself something to drink. So that you see the different buttons, here we go, if you don't see them, I'm going to label these. This is button number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 buttons, are we there? All right, so therefore, let's say that the person that went to Walmart was Bree. Bree went to Walmart, and she finished the shop, and she put her $1 in, and then she presses a button. And from now on, this will be my input. That's the button that I press, and whatever I get out, that's what I get out. That's going to be my output. Okay. So, Bree, what would be the button that you press? Number what? Number 6. Okay, and then you said you'll get a brisk. Okay. So then she got her brisk, and then she turns around and she's about to open it because she wants to drink, and all of a sudden she sees her crew, and they're like, hello. So then she's off. You know what? Here, I don't want anybody's cooties, so here's a quarter. So they give him a quarter. So then the next person up is Hector. Hector, what button do you press? 1, and he gets a Coke. All right. From there, Bree starts handing out quarters, and then Madeline, what button? 9. She gets a grape soda. Then from there, Garrison, what you get? 8, and he gets a Diet Coke. From there, Ryan, number 11, he gets a cactus cooler. And then from there, Alba, 3, she gets a old school Pepsi. Okay, I'm gonna stop right there. Now check this out. Everybody look up, please. So, what we just did is what we call a relation. A relation can be represented like this. But according to the definition, it says the collection of ordered pairs. Check this out. Here's an ordered pair. Here's another one, another one, another one, another one, and another one. You guys see that? Now let me write it out so you can see it. A relation is 6B, 1C, 9G, 8BC, 11 cactus cooler, and 3P. All right, are we there so far? Okay. So this not only is called a relation. This has a special name. This is called a function. Why is it called a function? Let me ask you a question. Guys, focus. So, this is called a function for a particular reason. Is the machine functioning correctly? Is it giving me exactly what it's representing here and here and here? Yes. That's why it's called a function, because for every one input, there's exactly one output. Are we there? However, Bree still has a couple people in her crew, and Britt goes next. She gets a quarter and she presses which button? 10. She gets a Dr. Pepper, and then from there, Deegan. 12. It's also a grape. Okay. And we'll do one more. About Lexi. 5. Okay. So therefore that's a H2O. All right. So check this out. Guys, focus. Up to right there, the machine is functioning correctly. But as soon as Bree says, you know what, I already finished my brisk, I'm still thirsty, but I don't want anything sweet. I'm going to go get a water. So she presses a button. She presses 5. Check this out. She puts a quarter, presses 5, but then she gets a Dr. Pepper. Who's that's happened to you before? When you put money in the machine, it gives you the wrong one? Okay, focus please. So, check this out. So, up to right here, the machine was functioning correctly. And if I kept writing all the ordered pairs, it will still be a function. However, up to right here, it is no longer not a function. So once again, a relation is all these points together, and if it's working properly, that for every input there's an output, then it's a function. But as soon as, everybody look up please, as soon as one of the inputs repeats, if it's not the same output, like here and here, therefore it's not a function. Are we there? Now let me show you with numbers. Here we go, to see if you can see a little bit clearer. Here it goes. With that same idea, if I gave you this, everybody look up. I got X, Y, and I got 1, 2, 3, 4, 1, 2, and 3. So check this out. In order for this to be a function, check this out. I get 10, 8, 15, 7. The 1. Here's the 1 repeated. For it to be a function, this has to be a what? A 10. For it to be a function, this has to be an... So far it's a function, right? However, what if for the next number that repeats, check this out, this one repeats and this one repeats. This one is a 7. Is it a function? No, because it's not the exact same number than here for here. Okay, yes. Yes, exactly. This is how it's going to look. That's why I wanted to show first with the soda so you can get the idea, but now do you understand now with numbers? Exactly. So that, write this down, example Q. Write this table down and copy these down and check this out. I want you to write asterisk, not a function. And then I want you to explain why. Put a little star, a heart, and I want you to explain why this is no longer a function. Go. So once again, this is not a function. So then if it's not a function, what is it? A relation. A relation. Okay? If it's not a function, it's a relation. What did we say a relation was? A collection of ordered pairs. Here's 1, 2, 3, 4, 5, 6, 7 ordered pairs. That's why it's called a relation. Are we there? All right. In the back, copy this example down. Example number 1. So we're done. We're done with identifying which one is a relation, which one is a function. Now we're going to get into graphing. So copy this down, please. Example 1 in the back, please. You're going to need more space. That's why you need to copy this one on the back. Example 1. Express the relation 2, 3, 4, 7, 6, 8 as a table, as a graph, and as a mapping diagram. And at the end, also write the domain and range. No, not the whole thing, just the black text. Okay? You don't have to write the blue stuff. All right? And then copy this down, copy this table, copy this graph, and copy this mapping diagram. So, the book's not going to give you and ask you to do all these things together. What I'm doing, I'm actually combining like 4 to 5 problems in one. But the reason I like to show it like this so that you guys can see the different representations of one of these relations. Okay? So check this out. First, if the book says, if we look up please, if the book says, express the relation as a table. The first thing you do, you make a table. Next, you label on your points, pay attention please. You label your x values. Which is my x value? The one on the left here. So this is x. How about this one right here? This one and 6. As soon as you identify those, you write them on your table. 2, 4, 6. Do that right now, please. Next, identify the y values. This is y, this is y, and this is y. So therefore you fill those in here. This is 3, 7, and 8. Okay? And right there, we're done with that part. If they just ask you for the table, at that point you will be done. That's it for that part. However, if the problem says, you express the relation as a graph, then you do this. Here we look up, pens down. Here it goes. So imagine that you don't have this table and you don't have the mapping diagram. So you do this and you start with this. Again, you label all of them. I'm going to start with the color red to put my first point. X value is 2, which is right here. And it says 3 of y. That means I'm going to go up 3 steps. So from here I go 1, 2, 3, and I plot my point. Next one, 4, 7. 4 is right here, and I go 7 steps up. 1, 2, 3, 4, 5, 6, 7. Plot my point. And the last one, this one, 6, 8. This is 6, 1, 2, 3, 4, 5, 6, 7, 8. And I'm done. Copy that, please. And the third part, once again, imagine that the book, for the problem, they don't ask you for the table or the graph, but they ask you to represent it as a mapping diagram. Let me show you how that works. Pens down, eyes up here. Now, at this one, I do want you to pay attention well, because this is a little bit different than the rest, even though it looks very similar. So check this out. First things first. They're going to give you this. You draw your mapping diagram. You draw a rectangle for the x, a rectangle for the y, label it mapping diagram. And then you go, okay, my x values are 2, 4, and 6. Okay, those go here. 2, 4, 6. And then you look at your y values, 3, 7, and 8. 3, 7, and 8. And some of you are thinking, well, that's silly. It looks almost the same as this. Yeah, the only difference for here, we need to indicate the relation. Let's see. What does the 2 correspond to? Which one does it correspond to over here? The 3. What does the 4 correspond to? 7. And what does the 6 correspond to? 8. That's what we call mapping, when you draw the correspondence. Okay, copy that, please. So now, let me show you the difference. Focus, please. Let me show you the difference between a table and a mapping diagram. Let's say that they gave us one more point. I'm going to write it right here. 2, 9. Okay. I just made this point up. Everybody look up, please. Look up to the screen. I'm making up a point. So don't think I'm using any formulas or anything. I just made it up. 2, 9. There it is. But I'm asking you to put it here together with this relation. So now it's part of the relation. So we already filled this table. What's missing? 2, 9, right? So I'm going to write it here. What is the x value? 2. And the y value? 9. So there it is. And now it's part of that table. However, pay attention, please. When you fill the mapping diagram, you look at it, we have 2, there it is, 4, there it is, 6, there it is, and another 2, but I don't rewrite it. No, I don't rewrite it. However, let's see, y values, 3, yes, 7, yes, 8, yes, which one is missing here? 9, so that one I do write. So think about it. What's the difference between the table and here? That over here we don't do what? Rewrite the numbers. If it already appears once, then you don't have to rewrite it again. However, check this out. We do have to state the correspondence or the relation. So let's see. 2 to 3, there it is. 4 to 7, there it is. 6 to 8, yes. And how about 2 to 9? Then you go from here to here. Copy that, please. And also, I'm going to go ahead and graph it so that we have it also. 2, 9. 2, 9 is right there. Copy that, please. So let's see. It says, express a relation as a table. Did we do that? Yes. As a graph. As a mapping diagram. Now the last part. They want us to write the domain and range. Check this out. Domain. There it is. The set of 2, 4, 6. What do you guys notice the domain is? All x values. Is that correct? However, without repeating. So you notice that I did not write a 2 times. Okay? The range. The range is all y values. So therefore my range is 3, 7, 8, 9. And once again, whenever you write your domain, which is all x values, or the range, all y values, make sure you don't write repeats. Everybody got it? All right. Questions, comments, autographs? No? All right. So, with that said, copy this next one down, please. So now we have an example for that. Okay? Copy this next one down. Example 2. Not that one. Check this out. Before you copy this one, everybody look up. You're not going to copy this one. We're going to move on to another one. But if they give us this relation, do we know how to make a table out of it? Yes. You draw your x and y. Which are my x values? 1, 2, and 3. What are my y values? 3, 4, and 5. So it should look something like this. Yes? If they ask you to graph it, 1, 3, 1, 3, 2, 4, 3, 5 should look something like this. Is that correct? And the mapping, once again, with correspondence. Are we there? All right. So now, copy this one down, please. Example 3. Example 3. It says, give the domain and range of the relation. You're going to draw an x-axis, y-axis, label this, and draw your little segment like that. So, as you're finishing up your graph, I want you to write domain. You're going to do a bracket, leave a nice space in between, in another bracket, and then range. Bracket, nice space, and bracket. And then I'll show you how to fill that in. Pens down, eyes up here. So, if we look up, some of you are saying, it says, give the domain and range of the relation. You're like, is this a relation? Yes. Because in order for us to have this graph here, we need a lot of points, don't we? And what are points? Coordinates. And what did we say a relation was? A collection of coordinates. Are we there? Or ordered pairs. So check this out. In order for me to know my domain, I'm going to get my pencil, and from far away you can do the same, and I'm going to scan it from left to right. Let's say this is your pencil. From far away, see if you can match it up to that one. Get your pencil, aim it at that, and you're going to overlap it with this, and I'm going to move it from left to right, and as soon as it touches that graph, not this graph, the red one, right there. What number, what value of x is it down here? 1. 1 right here, right? So check this out. So my domain starts at 1, less than or equal to x, less than or equal to, check this out. Where does it end? I continue going. It ends at 5. And then you label it 5. Does this look familiar? Yeah, that's what we've been doing with solution sets, right? So check this out. To find the y, since now for the y we need these values, I'm going to put my pencil sideways, and I'm going to start from the bottom to the top. Scan it. There it is, right there. Where does it start? Let's see. It starts at 1, 2, 3. 3. So this is 3 less than or equal to y less than or equal to, and where does it stop? Let's see. At 4. 4. Let's find out. Here we look up, please. If it starts here and it goes up to here, all those are y values, right? So look at it. If from here, this is a 3, and right here is a 4. Y is in between. So is y greater than 3? Could it be equal to 3? Let's see. Is this a solid point? Yes. Is this a solid point? Yes. We got it? All right, so in your homework, they're going to ask you to do a couple of these also. So, homework for tonight is found on page 209 to 210, numbers, what is it? 2 to 22, even. Okay, have a good one, guys. Enjoy your homework. See you guys tomorrow.